Welcome dear friends, this is Mathdoctor and let's begin with the base theorem.
It's Mathdoctor.
So in this lecture, we are going to look at the next part of the total probability theorem. So in the previous lectures, we have discussed about the condition probability and total probability theorem. So now let's begin with the main part of the chapter, that is base theorem. So base theorem simply indicates, let's look at the example. If we have two bags, bag number 1 and bag number 2, let's suppose we have third bag 2. It contains the 3 white balls and let's concise now only do two bags. Let's suppose we have 2 bags and it contains the 3 white balls and 2 black balls, and it contains the 5 black balls and 4 white balls. Then what we go to look at in the condition probability we have learned, we have given the condition let it must be in the room number 1 and then we are going to find the probability of white ball or the or the black ball. So but what happened if we reverse the process, because here we know that it would be 3 by 5, because we are concising ourselves to the bag number 1 which contains 5 balls, 3 white and 2 black balls, and here it will be 2 by 5. So that's the condition probability. So what happened if we reverse the process? So if we reverse the equation, that we find the ball from the bag number from any bag, that is we're going to see next. We have just take the white ball from any bag, then we have to find what's the probability that it is in the room bag number 1 or bag number 2. So it can be very much critical for us to find the probability of that, because we are not concising ourselves to any particular bag. We are asking about that we have taken the white ball and we don't know whether it is from the bag number 1 or bag number 2. So we have to find the probability of that. Here John Bayes gives us the formula for driving this particular condition for calculating this problem. So let's look at what Bayes theorem exactly tells us. So here we're going to see if we have to find probability of bag number 1, and we have to find what's the probability that white ball we have taken from any particular bag, it is taken out it from the bag number 1, because we know here we have 5 balls and here we have 9 balls. So now we're going to find what's the probability that ball must be from the bag number 1 and it must be white, and divided by ball must be white. This is the condition because we have given, and plus we have the probability that it must be. This is the total probability theorem which we have learned later. So this is the probability of finding white ball, okay, from the both the bags. That is simply going to be 7 upon 14. Okay, so let's first of all calculate this particular thing. So we know that using the lecture number 1 we have discussed that multiplication theorem. Using multiplication theorem we can write it like that: probability of white ball from the bag number 1 dot probability of bag number 1. We know that probability of choosing bag number 1 is obviously 1 by 2. So it must be right as 1 by 2 into this particular thing, which we know very well, 3 from the bag number 1, because we have applied the condition. So here what we're going to calculate is that it must be in the bag number 1 and it must be in the bag number 2. It is the total probability, and we have to find the probability of it. It must be in the bag number 1 only. So that's the idea. We can easily find this particular thing rather than this thing. Okay, so here there is a very big difference between both of them. So probability of finding white ball from the bag number 1 is simple, 3 by 5, and in this case 2, we have probability of finding white ball from bag number 2 dot probability of bag number 2 using multiplication theorem. So now we're going to just write here 1 by 2, and here we're going to find the bag white ball, that is 4 by 9. So that's the case. So we're going to take this common thing here, and now 27 plus 20, that is going to be 47 by 45. No, 45 90. So that's the answer here, 47 by 90. And what's the probability of this particular thing? We have find here, that is 1 by 2 into 3 by 5. Now it becomes easier to us to solve it. So 90 1 by 2 must be cancelled out from here. It is 47 upon 45 into 2, and it is 1 by 2, so it would be cancelled out. So it is going to be 3 into 45 upon 5 into 47, that is 9. This is 27 upon 47 is our answer. So this is going to be very much easy if we just see what John Bayes wanted to tell us. So if we see practically, we don't want to find this thing using this thing to this. We have to calculate in this using the Bayes theorem. So if we have given the condition, that is previously we are going to look at if we have given that we have chosen the bag number 1, then we are going to find the probability of white ball from it. But what happens if we reverse the process? Then we use this Bayes theorem. So it simply indicates, in a simple manner, we're going to see probability of finding the bag number 1 and indicates that both things should be happening. So we must have white ball first of all. Then also we have to find it in the bag number 1. And what's the total probability? It must be in the bag number 2 plus bag number 1. So that's the total probability theorem we're going to just see in this Bayes theorem. We're going to use in this Bayes theorem. So that's the idea about the Bayes theorem. I hope you enjoy my lecture. Now let's solve some examples. So let's look at the question number 1. So in the question number 1, we have given that there are 51 cards and 13 cards drawn at random. It is found to be red. Now what's the probability that the missing card is black? So let's say event is black and A is happen, but this is the reverse process. And now if we remember the condition probability, if we will given like this, so EB denotes that the event of black balls, that is 26 by 52, we know that 1 by 2, because there are 26 black cards and 26 are red cards from the whole 52 cards. So that should be 1 by 2. So these denotes the, first of all, probability of black card and the red ball and the red card. So it would be 1 by 2 because there are 26 black and 26 red from the whole cards. But we have 51 cards and 1 is lost. And what's the probability that it is black card? Now, if we reverse this process, let's imagine this question in a different way. Let's say we have this particular thing. We have A denotes this event. If we say that the missing card is missing card is black. And what's the probability now? We know that then if your missing card is black, here it should be 25 black and 26 should be red. Now we have to find what's the probability that first 13 cards drawn and it is found to be red. Then it must be written like that because we know that we have 51 cards from which we have this 26 red and 25 black, and we have to find first 13. So it would be case like that. It would be like this. Combination, heavy use permutation combination, and you must have to watch those lectures to perform this particular calculation. So it is the selection process we will learn in the combination and permutations chapter. So if we have given, let's suppose if we have given these cards 26 red and 25 black, now we have to find first of all the event that we have given 26 so here the case is like that. We have to put some 13 card from this, and what's the different number of cases we're going to write in this way. Number of cases should be like that. C26, and it would be like there are, because we have 26 red cards and we have to find it is red, it should be red. Okay, so we have 26 red cards and we have to put first of all we have given the condition that we have 26 red cards. We know we are using this particular condition because we have lost one black ball, and that is why we have 25 black cards here and 26 red cards. Now we know that we have 26 red cards and we have to find 13 cards that is randomly put from the whole 51 cards, and it is found to be what's the probability that it is found to be red. It is found to be red. First 13 cards drawn is red. So this can be calculated in this way. So what's the probability of putting the whole cards, and it must be like that. Now it must be written like that: C26, 13 and C. It must be written like that. First of all, using condition probability. Now we can use the condition. Here we can write this. This is half. Okay. Probability of this is half. And now probability of EB and A should happen. So A indicates that first 13 cards drawn is red, and EB indicates that we have 26 red cards, not 25, because we using this know that we have lost. EB indicates that we have lost card is black, and now we have 26 red cards, and the probability should be like that, 26, and we have to put 30. Now that's the case. So that's the idea. Now in the similar way, we're going to find out the probability of A such that EA has happened. EA has happened indicates that, sorry, E red has happened. It means that the missing card from this 52 cards is red. So the probability should be like that: A and E red upon probability of ER. Because here we know the probability of this thing, and it must be like that because we have first 13 card drawn is red. So we are pending with 25 red cards, not 26 red cards. Now it must be 25 and 13. It must be right like that. So now we're going to find the probability of this thing, which we have given. we have find the in this question we have to find the said that first 13 random cards you drawn, that is red. So then what's the probability that the missing card is black? Now we're going to look at the main part of the question. So that should be written like that. Must be written like A and EB right. It must be written like because we know the probability of this is probability of finding into EB plus probability of finding E red into probability of A and E red. Now we're going to see this as 1 by 2 and this could be right like probability of it, that is 26 into 13 and half 26 into 30 plus 25 13 into half. It will be cancel out from half will be cancel out taken at common at here and here, and it will be 26 13 plus 25 13 26 13. So that's the idea about this thing, and now let's sum up this question. 26 13 upon 26 13 plus 25 13. So it can be written, there is separate formula for it. So it can be taken out as common thing here 2 26 13 and 13. Now it can be written like now 13 can be taken out from it and it must be at 12. 13 and it will be 2. Okay, so it will be 3 into 25 upon 13 and 13 factorial, that is must be the answer of it is 2 by 3. So that's the answer. Now because we know it gives us 25 on 13 factorial into 12 factorial. Similarly in this way 25 factorial into 12 factorial. So this can be written as that. So that's the answer of it. So this is how we are just looking at the question and follow some particular approach. We have to determine first of all events. What are the events we are given? So in this question is simple. Is if we have 13 cards first drawn and it is found to be red, what's the probability that the missing card is black? So that's the question. So it is the probability that the missing card is black. Okay, so that's the idea. It is equals to 2 by 3. So I hope you enjoy my lecture in this way. For any doubts, please follow my Telegram channel and put your questions on it. And don't forget to like, subscribe and share my channel. Thank you all.